Welcome to the CAV Chronicles, exploring the scenario-based validation for safer mobility, a podcast where innovation meets exploration. Join us as connected, cooperative and automated mobility experts guide you through the cutting-edge world of scenario generation, virtual testing and other transformative advancements shaping the future of mobility. I'm your host, Iain Macbeth from ERTICO, the European Intelligent Transport Systems Association. As part of the SYNERGIES project, we collaborate with leading partners to drive progress in CCAM systems. Together, we'll navigate this dynamic landscape and uncover the technologies and ideas redefining our roads of both our urban and rural environments. Let's hit the road towards a smarter, safer, and more sustainable future.
Hello, everybody. Welcome to this second podcast in the SYNERGIES podcast sessions. We're going to be talking today about data-driven developments and how we advance best practice in data collection within the SYNERGIES scenario data space. So today we have three guests joining us. We've got Elena, Clement and Marcel. So I'll just get them to explain what their role, who they are and what their role in the project is. So perhaps we go to Elena first.
Hello, my name is Elena Daskalaki. I am from ICCS, the Institute of Communication and Computer Science from Greece. We are one of the partners of SYNERGIES, and we are the leaders of Work Package 3 of the project that is dedicated to the collection of data from multiple sources for scenario generation. Thank you.
Thanks, Elena. We've also got Clement with us today.
Yeah, so I'm Clement Val. I work at CESAR, which is a French research institute about road safety. In SYNERGIES, we are in charge of two tasks, task 4.3 and 5.2. And especially 5.2 means that we are in charge of the efforts in SYNERGIES that are developed to convert data into scenarios.
Great, thanks, Pavel. And last but not least, Marcel.
Hi, everybody. I'm Marcel Sonntag. I'm working at IKA. It's the Institute for Automotive Engineering of Aachen University in Germany. There we are also part of the SYNERGIES project, but I personally here can represent another project. It's the HyDrive project. It's to some extent linked, as we are there also gathering data, deriving scenarios. So this is what I want to bring to this discussion here, to also give another perspective and maybe show some connections.
Super. Thanks very much, Marcel. So we've got some great experts here. I'll attempt to introduce the topics. I'm not the technical person in the room, so I'm going to give the floor to Clement and Marcel. But firstly, Elena, perhaps you could just give us a brief recap on SYNERGIES' objective with the platform and its marketplace.
Yes, sure. So SYNERGIES is a European project that aims to create a platform to facilitate the testing and validation of CCAM systems. This platform will comprise two main components: a scenario dataspace that will provide scenarios widely accessible to stakeholders that wish to use them for testing. And also it will comprise a marketplace that will contain tools for extraction and generation of new scenarios and processing of training data.
Thanks, Elena. That's great. So going into role of data, Clement, perhaps you could just give us an overview on the role of data for scenario generation in the CCAM from a CCAM perspective.
Yeah, so the aim of scenarios first is to define circumstances, interactions, all the things that may happen in traffic. And those should exist as a reference to specify first automation and safety systems and to verify or validate, for instance, in simulation, but also with physical testing, that a system actually does behave in a safe, in the way that we want it to behave. This means that if we use such a database as a reference, it needs to be grounded in reality. We can, of course, imagine all the things that may happen in traffic, but we might miss some things, and we might not know their representativeness. So we need data to be able to better represent the complete and actual circumstances that the system is going to meet in traffic. So that's the role of data collection. And the role of data collection in the context of creating a scenario database is to identify what kind of situations happen in traffic, how often do they happen, and also what are the usual consequences. And that's especially important in the case of accidents. If we model accidents, actual accidents that happened in the form of scenarios, it can also allow us to assess the safety of systems in terms of how many accidents or what kind of accidents are avoided or mitigating. It also allows to identify situations where an accident where we will never be able to avoid an accident without technological change. For instance, maybe we need to be able to see through things. So maybe we need some kind of communication, V2X, to be able to address certain accidents. And finally, data is also useful not only to create reference of situations which happen, but also it's useful to develop models, because in the end, if we do some simulations to validate the behavior of a system in response to some events, the system itself will react to those events. So the system is in the loop in the simulation and it changes what happened. And maybe the other road users, the other actors of the simulations need to react to what the system does. So for instance, if you have a system which breaks, you need, and there is a vehicle following the system under test, you need maybe to also model the reaction of the following vehicle. So you need some reference models of behavior, and data can also be useful for this kind of model creation and design. So to summarize, the data is necessary to identify what kind of situation happened on the road, how often they do happen, how people usually behave in those situations, and what are the consequences usually of those situations in terms of safety.
So thanks for that, Clement. That was a really great explanation there. Now, turning to Marcel, what does the data actually look like, or what's being recorded from sensors and domains, etc.?
Yes, so I think Clément already gave a quite nice overview that there are very different purposes, and we also need to have in mind that there are different sources for data. So I can now maybe give the perspective from HighDrive, what we are doing in this project, because it's very important to notice that there is already data being collected in some points. There's already some databases that might be used, for example, on accident data that Clément also briefly touched. So this is what we always need to have in mind. So I can tell you what we are doing in HighDrive, and this also leads to the fact, how does our data look like? And then maybe briefly introducing HighDrive. So the project is driven by several OEMs in Europe that want to further develop automated driving. So they want to defragment the ODD, so extending ODDs, extending availability of the automated driving function. And they want to do this by using enabling technologies. So it could be some connectivity, so V2X, it could be some improved positioning, some machine learning based stuff, and so on. So there's a lot going on in this project, and we are doing real world tests of those developed extended systems with like actual automated driving functions in traffic. So I guess this helps to understand what kind of data are we collecting and what is the purpose. So on the one hand, we are collecting data, very detailed data on the actual systems to evaluate like the enablers on a technical level, checking some latencies and so on. But on the other hand, we are also collecting data to analyze the behavior of the automated driving functions in traffic. And this is what we then compare to manual driving data, also comparing to data without those enabling technologies to see what does this add to the automated driving, how does it behave then in actual traffic, and what can we then expect in a large scale deployment. And this is what's our focus in the project, or my focus, doing those evaluations. And this is now the connection to SYNERGIES. We are collecting there also scenario data because the evaluation is scenario based. So we are collecting there those driving scenarios. We're checking in specific, for example, intersection scenarios. How are there some interactions with other road users? But we also especially check for edge cases. So you'll also touch this point briefly in the first episode of this podcast. So it's about a very rare and unforeseen driving scenarios that might lead to some challenges for automated driving systems. So this is why we are collecting a lot of data, a lot of different use cases, a lot of different test sites. And in the end, we are already building up also a high-drive driving scenario database with this specific data. So this means that the data that we are collecting for this like broader evaluation scope is mainly about some ego vehicle behavior, so the dynamics, some internal signals, but it's also especially about the dynamic objects that are there in the environment, also some infrastructure data, so on, for example, lane lines and intersections that are there. So this is what we are collecting in HighDrive, and this is also something that can be then further used in different purposes, for example, then in SYNERGIES.
Super. Thanks very much, Marcel. Glenn, we've heard some things there about the edge cases and that side of the data collection. From César's perspective, have you got anything that you'd like to add?
Yeah, we want to add that to create scenarios, basically, any kind of information can be used and can be useful. We can use general statistics. We can use police reports for accidents, safety critical events, which have been observed during field operational tests with automation system, as Marcel evoked, or even with ordinary driver in their ordinary vehicles in naturistic driving studies. In the context of SYNERGIES, the data that we use, at least in terms of volume and of effort, is mostly what we have called in the project scenario source data. So it's very rich data that is really collected for the purpose of scenario generation. And when I say very rich data, it's data that represents the interactions of all the road users between themselves and in relation with the infrastructure. So that means that in this scenario source data, we need a very precise description of the infrastructure, of the lanes, of their geometry, of the markings, of the traffic signs. So very detailed maps and precise trajectories, detection of all the road users, their categories, their speed, their acceleration. So yeah, any kind of data can be useful, but in SYNERGIES, most of the efforts will be dedicated to this very rich kind of data. So this scenario source data will come from different sources. In SYNERGIES, it will come from instrumented vehicles, it will come from drones, it will come from roadside units, and we will even generate scenario source data using simulation, using artificial intelligence, and so on.
Great. Thanks, Clement. So we're collecting all this data now from multiple sources. There's always the question of all data is useful data, just because we're having to think of so many different dimensions. But having collected all the data, how do we go from all that data to actually building the scenarios that we're going to be using and sharing within SYNERGIES? Perhaps, Clement, if you just want to continue on that one.
Yes. So to create scenarios, first, just say that when we say scenario, it can represent many different things. And we have some vocabulary to describe that. So there are first what we call functional scenarios, which is a very high level natural language description of some kind of interactions in traffic. We speak also about abstract scenarios, which is in a way the formal mathematical representation of a functional scenario. So it describes in a formal way using language or in reference to an ontology, it describes what are the interactions that constitute a specific scenario. Then we speak about logical scenarios, which define and model the way that a specific abstract scenario is described. Because an abstract scenario describes, for instance, we are following a vehicle, but a logical scenario will add the notion of parameters in relation to the abstract scenario. So, for instance, if we're following a vehicle, we would say at which distance, at which speed. So those are parameters in logical scenarios. And then when we speak about a specific instance, a specific observation, where the values of those parameters are set, we speak of a concrete scenario. So a specific observation, a specific traffic situation is a concrete scenario, which we can describe by defining values for parameters in a logical scenario, which itself models the space that can be covered by an abstract or functional scenario. And in addition to that, we also speak about test scenarios, which is what we actually do when we assess a system using a scenario. And when we speak of a test scenario, it means that, for instance, we will use it in simulation. So it means that we need the scenario to be described in a specific format that can be used in the simulation too. And also when we speak about a test scenario, we speak of the outcome that is expected and the performance indicators that we are going to calculate to say whether we have reached the desired outcome or not. So scenarios can be a lot of different things. And it means that there are a lot of different ways to create a lot of different kind of scenarios from data. So there are multiple approaches. You could, for instance, create abstract and logical scenarios with a very formal approach so without data, by just defining, not that simple, but by defining an ontology that describes everything that may happen on the road, that may happen in traffic, and then search for or go through all possible combinations with it within this ontology. And then you would use data to say statistically how much which combination represents. So you would use data to say how likely a specific combination is to happen. And in other terms, you would use data to create multivariate distributions of parameters in a collection of logical scenarios by combining multiple observations, so by combining multiple concrete scenarios that you have observed in the data. That's a very top-down approach. But if you just do that, you will realize that in your data set, there will be a lot of instances, a lot of situations which you didn't classify, because there are a lot of things which you didn't think about beforehand when you design your collection of logical scenarios or abstract scenarios. And this means that the data will help you challenge this preconception about what may happen or may not happen on the road. And by challenging those preconceptions, you will be able to improve your collection of logical scenario, to add new logical scenario, to maybe design them in a different way, and maybe even challenge the ontology. So the space in which those logical scenarios are defined. So all of this is a bit abstract, but you see that we need data for both top-down and bottom-up approach. And in some cases, we also use it in much simpler ways. For instance, if you have accidents modeled as scenarios, maybe you just want to see how many accidents you will avoid with a specific innovation. And in that case, maybe you just want to directly convert the data, the observations from the accident into a test scenario, so into something that you can directly simulate. So in this instance, it's just is not that simple, but It's a conversion of specific ways to represent data into another specific way to represent it. So yeah, we can use data in very different ways depending on what we are trying to achieve. And in terms of how we use it, again, there are multiple different approaches. You can have very brute force approach, where you have many people coding algorithms which will use the original data to directly detect some scenario. Maybe you want to have some more formal approaches, where you decompose your data into interactions, into events, into maneuvers, and then combine them in relation to a formal description of what you're searching for, to interpret basically your abstract scenarios with software. You can use artificial intelligence as well. And all those approaches are going to be explored by different partners in Synergies.
Thanks, Clement. That's super interesting, and just shows the complexity and the sheer number of scenarios that have to be considered throughout the project. I was just thinking in my own mind, if one concrete proposal is a vehicle following a truck and the 30 kilometre an hour set of road, that's one concrete thing. But then if it accelerates when it comes to a 50 kilometre delimited stretch, or it has to reduce and so on, each of those has to be, each scenario has got to be built. There's road coefficient, vehicle size, gradient, all of those are going to be different for each one of those scenarios. And it's super interesting.
So basically, we are trying to model reality. And as you know, reality is quite complex.
Yes. And it kind of then perhaps gives our audience a sense of just how much needs to be modeled. And each one of those components has to be sort of absolutely tried and tested, simulated in the room where it's as well. So Marcel, we've been talking a lot about scenarios. What's perhaps Hydrive been doing in this space?
Yeah, first I want to thank Clement because he really pointed out, there are very different purposes, very different approaches, and there's not always like the right or wrong. So it's always depending on the context and so on. So this is really something I want to stress. So this is also why I can only now give like the details for Hydrive. So as said before, our main goal for Hydrive is the data analysis of those specific operations that we have, but we also want to use the data that we're collecting for more purposes. So for example, like test case derivation, also something that Clement touched before. So to achieve that in the project, we then defined a very specific driving scenario concept that matches our purpose, that covers the use cases, the ODDs that we are having. So in all, we have around 35 functional scenarios defined. So it can be something like following a lead object. It can be something like a lane change at an on-ramp. It can be something like turning at an intersection with given interactions with other road users. So it is quite diverse. And based on this specific driving scenarios, we are searching then for concrete scenario instances in the data. So to achieve that, this seems maybe quite straightforward, but it's not that easy. So you need to have in mind in Hydrive, we're having like around 20 different operations. We have different operation owners, vehicle owners. We have completely different use cases that are covered there. So it's not easy to try to get this all together. So in Hydrive, we developed, on the one hand, a common data format for Hydrive that really allows us to cover the right signals that we need to cover or to enable data recording during those operations, that we have everything we need and don't in the end feel like we missed something. And we also developed a very extensive harmonized processing toolchain. So based on this very specific data format, we can then, as soon as this is converted evaluate all the data that we get from our operation owners. So it doesn't matter from which country those operations are or from which use cases the data is. So this is what we try to achieve in HYDRIVE, and we already achieved this to enable this harmonized evaluation then. And this is also based on the scenarios that Clément mentioned.
Thanks a lot. So we mentioned about data formats and sharing of data. Is there any data that is problematical that maybe we can't necessarily use or anomalize?
It's also very difficult. So in the end, what we want to collect also depends on the purpose. So this is always what I want to stress. And therefore, we really need to think of what do we want to record and what can we record, because there are definitely some challenges to collecting data. I mean, in an ideal world, we could always collect anything in the best quality and store it for however long we want to have it. But we need to be aware of what can be shared, because in those purposes now, it's the same for SYNERGIES, but also for HYDRIVE, we want to share the project within the project, the data within the project, but also some data with project externals. So when we are then thinking of, for example, detailed camera data, so perception data, one thing that is always a difficulty are GDPR reasons. When we can recognize there are some people and so on, this definitely leads to issues. But also in HYDRIVE, we're having quite specific issues when it comes to recording automated driving data, because I already said it now a couple of times, we have different operation owners and therefore also different competing OEMs in our project. And what we really need to ensure when creating our driving scenario database in the end, that this is not in the end like a benchmarking database or something that allows re-engineering, because if this would be the case, then probably the operation owners would not share the data. So we need to ensure that the data that we have in this database does not allow to see who was collecting the data. So this also then comes, for example, when we talk about camera data, to some issues. For example, when we have, for example, camera data that is obviously from Munich, we could think of which OEM might have provided this, the same for other cities. So this is what we need to really be aware of, and where we need to take some countermeasures. So we had also like long discussions in HYDRIVE. We also have some experiences from earlier projects, and we really achieved still to collect the data, to share the data. And I mean, the solutions for this are maybe sound straightforward, but it is not. It's on the one hand trust, so that we really do only with the data what we in the beginning agreed on. We need to anonymize data, and we also need to carefully select signals. So as said, for example, raw camera images is difficult to share then in the whole consortium. There we need to have like bilateral agreements to share also this. So this is one point, but we also need to segment the whole trips that we have into individual scenarios with like a shorter length, to also there make it not available or possible to assign some trips to specific OEMs because we identify their specific turns and so ever. So there's a lot of things that we're doing, and it also works. So this really allows us to share data within the project, but we also want to share data with the public. And there we focus then on some data that is still interesting, but maybe not too sensitive for like a specific operation owner or OEM. So this is then especially manual driving data, which we are collecting as well, but it's also about edge cases where we have a very high importance for all the involved people in CCAM activities, where it is really worth sharing those, even though there might be some things that could lead to some issues here, but it's only about a very limited but highly interesting number of scenarios that we have.
Thanks, Marcel. It's really interesting that the perspective there about you have to consider GDPR and personal data protection rules and things like that, but also bringing in the commercial sensitivities and IPR of different partners and what can be shared easily and what's more sensitive to share. I suppose, Clement, from that perspective, if you're trying to validate this data, how do you go around that?
So to be confident in the usability of data, we need to be perfectly conscious of the limit of a specific data set. We need to know the representativeness of a specific data set. For instance, if you collect data only in summer, what you have is representative of what happened in summer. And if the operational design domain of the system you are trying to validate is also supposed to work in adverse weather, you need to know that your database is skewed toward easy weather conditions and the probably doesn't contain enough adverse weather. So representativeness, completeness is very important. And if your data set is not representative or complete, it is at least representative of something, but you need to know of what it is representative. And then you need to know the actual quality of the data set to be able to know what you are going to be able to use it for. We don't need the ultimate quality all the time. For instance, we used at CESAR the UDrive database, which is a network driving study database. So network driving study means we put some sensors and some data loggers to ordinary drivers' own vehicles. So of course, if you do that, you can put lidars, cameras on their roof. You have to make simple instrumentations. So the data is of limited quality in a certain respect. But if you do this kind of experiment, you can collect millions of kilometers and they correspond to real behavior of real people. So there is a trade-off here between the quality of the precision of the sensors that we use, but another kind of quality, which is the representativeness of the behavior that we collect. And we use this UDrive database to create not precise parameter distribution of interactions between producers, but we use this database to identify all the safety critical events or safety relevant events. So all the difficult conditions and to make sure that all those kind of scenarios were represented as logical scenarios that we were then going to characterize with better instrumentation later. So really, you need to have a good knowledge of your data to be able to use it. You need to know its limits, but if you know its limits, you can use different kind of data of different quality, but for different things.
Thanks, Clement. So obviously we're sort of creating all these different scenarios, but there must be times when you come across the situation where the scenario doesn't actually exist. You haven't got the data for that. So how do you go about capturing data for something new that hasn't been thought about before?
If it's new, it's new in the sense that probably you have observed it, so you have data for it. But the question is, do I have all the data that I need? And I guess it depends on what you're trying to achieve. If you're trying to create a database of scenario that will be used to validate a specific kind of system or a specific system whose operational design domain is clearly defined, then you need to make sure that you have the data that covers all the conditions of this operational design domain to make sure that you have perfect coverage in terms of the scenarios that will be used to validate it. If you're trying to make more general repositories of scenarios, in a way what we are trying to achieve in Synergies, you need to identify, maybe in broader terms, what is missing in the current scenario databases. And for instance, in the context of Synergy, during the call that led to this project being founded, the European Union had identified that there were gaps in the multiple scenario databases which exist in relation to urban environment and rural environments. Because until now, most of the big efforts in terms of scenario database creation had been made for L2 or L3 systems, so systems which are mostly used in simpler environments on motorway. And it means that those databases are skewed. They contain mostly scenarios relating to motorway or this kind of environment. And now we know that we need to collect more data and model scenario and maybe adapt our instrumentations and the way we create scenarios to be able to tackle urban challenges and rural environments.
So Marcel, Kamal was just explaining some of these scenarios that were missing between an urban and a rural scenario situation as part of the Synergies program. Is that something that you've found in HiDrive as well?
Yes, definitely. So there again, we have to have in mind that we are coming from a slightly different perspective. So for us, it's about like really developing and testing specific systems that we already put on the streets and that we actually operate. But it goes hand in hand with what we do with our enablers. So there we want to close gaps that we see like in the ODDs. And one reason for this might be that there's really lack of data. And this also leads to the fact that we have quite targeted operations. So we are not just driving around for all of the operations, but we really have some targeted locations, some targeted ODD conditions that we look at. For example, we are looking at tunnels, we're looking at cross-border driving, we're looking at driving in construction sites, and we are looking at this on the one hand for motorways, because there are still some need. But as Clément touched before, we especially also looking into urban data, because, for example, when it's about positioning, we have there high buildings that can lead to some GNSS occlusions and so on. So this is actually very important and very in line with what Clément said. So it's important to think of what are you testing, where are you testing, and what data can you get from this. So this is what we are also doing in HiDrive. So it's quite in line.
Thanks for all that super interesting commentary from Marcel and Clément. Elena, in terms of the future vision, have we got some milestones coming up on data collection that we need to be aware of?
So currently, all partners of Synergies are preparing their campaigns to collect data. Each partner has presented a different plan and will cover different situations or different setups. For example, some will work with rural areas, others with highways. Different choices of sensor modalities will be taken by different partners, etc. So we expect to collect highly diverse data, which is great, as this will offer us the possibility to extract and generate also highly diverse scenarios to enrich our database. And as Clément also mentioned earlier, apart from the real data that we will collect, we also plan to generate synthetic data either through simulation or through generative AI methods to enrich further our data pool. So this is where we are looking at this stage of the project.
So I'd just like to thank Helena, Clément, and Marcel for their time today and for their really interesting insight into the projects. We look forward to welcoming the audience to the next podcast. Thank you very much.
Thank you.
Thank you too.
Yeah. Bye-bye.
So, this is a good point to bring this podcast to a close. We'll be recording the next podcast in April, where we will talk about regulatory challenges and solutions in CCAM. We're also looking forward to the first anniversary of Synergies, with the next podcast being recorded at the ITS European Congress in Sevilla. Stay tuned.
Thank you for listening to this podcast from the CAV Chronicles, exploring the scenario-based validation for safer mobility on behalf of the Synergies project. Please refer to the description box for more resources, and don't forget to click the subscribe and follow button. Stay tuned for the next episode.